Welcome to TLR600VPN. Today we will be teaching you how to configure an edge router. This specific case scenario will involve the TP-Link router. It's the R600VPN router. It's a pretty powerful router with built-in firewall tools, along with some VPN networking capabilities. There's an array of bunch of other features, but we will go through a few basic setup menus so that way you can get your network configured and your business up and running. So let's begin. First, you will receive your router. You will want to unpackage it and then plug it into a power source. From here, you want to make sure that your main internet access or your main point of internet plugs into the WAN right here. Then you want to configure the router using this LAN port 5. This is where your computer is going to be plugged in. Once your computer and your internet access is connected to the router, we want to configure your workstation. So we have to open up Control Panel, and we have to configure the network to pick up the specific IP and gateway for this router. It will have its default IP, and I'll show you how to get it configured and inside the GUI options. So from here, Ethernet 7. We want to go ahead and click on that. Then we want to change the properties. Inside of properties, we want to make sure Internet Protocol version 6 is unchecked. Then we want to double click on the Internet Protocol version 4. From here, we want to configure to have the default gateway of the router. That would be 192.168.0.1. Then the subnet mask, it's 255.255.255.0. And then any specific IP on that network that's available. For me, I will choose a random one. I do believe this one should be open. So this should be the IP of the computer. This should be open, or for this adapter. Go ahead and click OK. Then you want to open up a web browser to configure your GUI station. So from here, we want to type in the router's IP. You will be prompted to enter in the password. So we want to make sure that we enter in a new password, confirm the password, along with a username. After you set your password, you should be able to access the GUI interface for this router. Once you enter in your password and username for the first time, you will be logged into the GUI system for this router. From here, we want to go ahead and go to Network and click on WAN. We want to change WAN to only be one WAN, and then we save. This may take about 1 to 2 minutes for the changes to take effect. After your device restarts, you should have a wide area network connection. And you can check that by going to Network, clicking on WAN 1, and then seeing that you do have a primary and secondary DNS, along with your default gateway, and an IP address. Next, we will configure the LAN portion of this device. So we want to go ahead and select an IP address for this device, along with the subnet mask. Alternatively, we could select Management VLAN, which we will go ahead and do. Then the server. So from here, we want to change everything. Before leaving this page, we want to make sure that we save any changes made. So we go ahead and do that. And then you will have to reach the router by the proper IP address, which would be 10.0.0.1. Now you have to change the IP scheme inside your Ethernet adapter one more time to reflect the gateway of your newly configured router. So that would be, for us in our case scenario, 10.0.0.1. Now you should have your WAN and LAN features enabled for this specific router. Next, we will go through a few of the firewall settings, a few of the behavior control settings, along with the VPN access. So I configured my WAN to have a static IP address because it was pulling the IP from a different system. It was pulling an IP from another edge router, so I needed to make those changes to reflect the correct information. And I do want to also add my internet provider's DNS that they provide to me. You could find that if you log into your main internet service provider's router, not to be mistaken with the one that we are configuring. So I will go ahead and add the primary and secondary DNS now. Now we could go back into the LAN settings, make sure that we have the correct IP address and the correct subnet mask along with any other settings. Now of course for this network it will already deploy an automatic DHCP server, and you could always change these settings and information over here. And as you can see, my computer, it's already picking up an IP address automatically, and then it's going to state the client that's currently connected. You could also do address reservations if you have various devices like printers or servers that you want to make sure has a specific IP address within the DHCP server scope. So this designates an address for a specific device. And this is usually for a static set printer, static set IP for server. Next we will click on IPTV. Here this we don't really necessarily need to set up because this is for a specific internet service provider that provides a certain kind of service. So we won't need to mess with that. Next is the MAC address. Now here you could clone your computer's MAC address and then you could have a factory reset. Now you just want to make note of this. This will probably be useful for specific things or security purposes. So when cloning current management's host MAC on the WAN port, the management PC should be connected to the LAN. Essentially cloning the MAC address, I'm assuming, makes it more secure. Next we want to go into the switch portion. Here you'd be able to see the statistics of your network. We want to go ahead and if you're doing any kind of reconnaissance or collecting of data, you will need to enable mirroring port. The reason why is because, for example, my computer is on port 5 and we want to mirror all these other ports. This will send a mirrored version copy of the traffic from these ports to port 5, allowing it to have Wireshark monitor everything that goes through this router. So we will save those changes so we can monitor directly from this computer. Next we could have the rate control. For here we won't make any changes, we will keep it at its default, but just know that you could prevent certain ports from having a certain amount of data travel through them. And this is good for if you have a phone service, you want the phone service to have the highest quality megabits per second, whereas the computers or the servers, you could have a lower megabit rate, and this allows for better quality control. Port configuration. Here you can configure the speed for each port, and essentially you could also enable flow control. So this, I'm assuming, allows you to control the type of traffic that travels on your ports. Next we want to click on the VLAN. From here we could create different VLANs specified for certain ports. So for example, our wide area network is on VLAN 336, whereas our local network is on 436. So we could create a new LAN by doing the following: clicking on add. Then next we want to go ahead and fill in the information. So VLAN ID and the name of the VLAN, along with selecting the ports. So setting up VLAN is fairly straightforward. You just want to know the difference between tagged and untagged ports. So here you could make a brand new VLAN, give it an ID number along with a name, and then you select the ports that you want to tag or untag. So we see all of our VLANs here created. Then from here we want to go to ports and make sure that each VLAN for that tagged port is assigned, and it's already automatically assigned. And then we want to save in both areas. For IPv6, we want to go ahead and keep disabled. The reason why is because on this network and case scenario, we will not be using IP version 6 for any devices, so that could remain disabled. To further expand on the VLAN subject, I have created a VLAN table. Generally, you want to make sure that each port on your router or switch is on a different VLAN. So for this example, we have the accounting department on switch 1, and that's on VLAN 100. VLAN 200 has a switch 2, and that's the management team. That's for administrative purposes, for administrating servers. Then we have the VLAN on switch 3, which is for sales, and so forth. So you would follow this similar tagging and untagging method to create one virtual LAN for each port, so that way each network is segregated. And this gives you more security. And then we go over to ports and make sure that each port is assigned to a different VLAN. And then you would want to save. So that's basically the concept of VLANing. There's much more to learn about it. It's a pretty interesting subject that could get very complicated if you have multiple switches and truck ports that need tagging for certain VLANs. So I will link all the other resource material to understand VLAN setup in the description. Before we continue the setup process for the firewall, behavior control, and VPN, we want to go to System Tools, select Admin Setup, go to System Settings, and then click on Redirect HTTP to HTTPS. And then go ahead and save. This will ensure that every time you log into your router's webpage, it will not use clear text port 80 to send usernames and passwords in clear text. Next, we will scroll over to behavior control. From here, we could do some pretty amazing things. We could basically filter out URLs, certain websites that the administrator doesn't want active during certain hours. Now, this kind of setting, there could be a whole different video on this because there's so much you could do with this feature, but I will show you the basic concept. So you would select any, and then you would type up your keywords. You could either type and enter a space, a comma, or a semicolon to divide the different keywords and websites. So we're going to filter Facebook and YouTube to see if this works. And then we want to add YouTube. We could give it a description, blocking social media, and then an ID if you like. Click OK. And now hypothetically you should be able to pull up a search bar that's connected to this specific router, and you should not be able to connect to Facebook. So as you can see, I did a search for face. and Facebook, and then we went to the URL. And as you can see, the URL it's thinking, and it hypothetically should not allow us to get to Facebook. We could do the same with YouTube as well, since we blocked that website. And if we go to YouTube, so during business hours, you don't want anybody to access YouTube or Facebook on your local network inside of your business. This is how you would filter those websites. There's a bunch of different options, like I said, that you can control within this type of interface, but it shouldn't connect to YouTube. And see, as you can see, Facebook, it cannot be reached. DNS probe, and it's due to the firewall. So this will prevent workers from getting these two websites. You could do that with a host of websites, and that's how you do that. Alright, inside the firewall, you have various options that you could implement to protect your network. So you have these pre-default settings that you could mess with. So here we could permit packets matching the IP MAC binding entries only, and that's if we have certain IP addresses binded to a specific MAC. This essentially means that every device on your network will only be allowed if the IP matches with the MAC address, and then it will get access. You could also have send GARP packets when ARP attack is detected, and then you could set the interval. So we'll go ahead and save that. Here we could do ARP scanning. It basically scans for address resolutions and see what kind of devices are on your network. So this is good for mapping out your network and finding specific devices that shouldn't be there. So we will go ahead and run a scan just to see what the results are. Alright, once we enter in our local address scheme of the range that we want to scan, it's going to scan the network for specific devices. If it finds a device, it will display it in the ARP scanning report. Okay, the scanning is done, and as you can see, there's only one address, and that's my current computer. My computer is the only computer connected to this router at this point. So that's what the results would look like. And then you would have your list here. And then from there you could bind certain addresses with MAC addresses and do all sorts of cool security things. So next we go to attack defense. Here we could enable certain perimeters for security measures. So this would protect potentially against in-map and things of that nature. So we'll go ahead and select the default, save it. This should be good for now. Now we can also do MAC filtering. So if we find a device that is a foreign MAC address on our network and we don't want it on the network, we could basically enable this and then deny the MAC address certain connections. Then from here you have the access control list. This allows you to control specific services for specific groups of individuals. So for example, we want to block Telnet. We do not want Telnet on our network. So we type up Telnet. The service is already listed. As you can see, there's a bunch of different services. We'll select Telnet and we'll select all. Then we'll do any, and there you go. And now this should block all Telnet attacks or Telnet logins. So we would follow this for various services that you do not want on your network. Alright, next area is preferences. Here we could create a few things. So first we go over to IP group. We could create a set list of IP addresses and then assign them with a name. So we will go ahead and do that now. You give it a name, either an IP range or an IP address and mask. So for this one we will create a range and we will consider the following IP scheme as the range for servers and other devices. So there's the range right there, and then we would give it a name. So here's the final version of the IP group and the address scheme. And you can do that multiple times. So that way it reflects your specific IP group that you want to assign to specific addresses on your network. So that way you have more control and fluidity over what happens for those devices. So here are a few IP address ranges that we created with the associated names for sales, IT, accounting, and servers. This allows you to have control over devices in specific subnets or IPs, and then from there you could apply time ranges, a bunch of different perimeters. So now we could go over to IT group or IP group and then do add. Here you would add the group name, and then you would select from the group dropdown. And here's an example table of the IP groups associated with the IP address range and name. So that's how that's done. And then from here you take these IP groups and you could apply it to certain firewall settings, VPN settings, things of that nature. And now we could set time ranges. So if you want your production network to only operate during production hours, you could do so forth. So here you have your working calendar, and then you would want to say from 7 to, 7 to 5 o'clock, right? Only Monday through Friday. And there you go. So essentially at 6:30 the network could be up, and you have it open until a certain time. Then you click OK. So now this is a bracket for production hours. Go ahead and press OK. And then you would just do that. So for off time. So this means for a specific time outside of production hours. Now we could assign that. So we go ahead and select all of Sunday, and then the early hours of the morning and of the evening. And this will serve as your non-production hours. Press OK, and then you could create like a lunch group, right? So your time range would be between a lunch group, which would be from 12 to 1. There you go. And then these could be applied to other various categories as well. Next we have the VPN IP pool. It's fairly straightforward. This allows you to assign IP addresses for a VPN pool when you set up a VPN network, which will come later in this video. We click on add, we give it a name, a starting IP address, and then an ending IP address, and then click OK. I already have made an example VPN access group, so there's nothing for me to do here except to leave this the way it is. The next tab is service type. Service type allows you to enable certain services that will be allowed on your network. So as you can see here, these are pre-designated services, about 11 services that they allow. And then you could add your own services. First you would type up the name, then you would type up the port and range. So for example, if you wanted to do remote desktop protocol, you'd enter 3309 right here, 3309 right there, and then you would go ahead and give it a name and make sure you have the proper protocol selected. So that's how to do that. I already created a few designated ports and services to be open, so that way I could use certain servers. So for example, with my Plex server, it uses port 32400, and I had to open up that service and then allow it in the firewall. Then I also had to enable VPN services for port 500, port 1701, and port 4500. So it's fairly straightforward. It's pretty easy to configure that. And then what you would do after you allowed a service, you would go over here to Firewall, get access control, and then you would go ahead and add that service. So as you can see, my service name for that port that I opened is under VPN 2. Fairly straightforward. So if your company has multiple subnets with different markets, you would want to use the Multi-NAT network address translation inside of the configuration tool here. For me, my network is fairly simple, so I wouldn't actually need to configure a multi-NAT. But this is the diagram here. So you would have your main TP link router. It connects to another router, and then you have your different subnets for each market. So essentially what you would do, you would create your individual subnets right here. So this would be an example entry. You have your sales department on WAN 1 for the interface, and then their actual subnet is on this following subnets here. And then you would go ahead and click OK, and then do that for each corresponding subnet and accounting or a department within that business. So here's how you would set it up. You would have your individual subnets and your departments separated by each proper subnet, and then this will allow it to actually transverse from the main router, the router that segregates these subnets, to the actual edge router or the TP link router, and then to the internet. So that's how that would be configured. I will provide more information about multi-nets and how to configure this router in the description, and generally it's fairly the same on individual business grade VPN routers. Next is one-to-one NATs. It's fairly easy to set up. So what you would do is, this would be for accessing a web server translated to a specific public address. And so you could basically convert your public address or your WAN address to match that web server. So the web server would go out into the internet and then convert into the proper WAN 1 address. It's fairly easy to set up, so I'll show you how to do that now. So with the next menu, it's one-to-one NAT. That allows you to map a server or a web server to a public IP address. Now this would be useful if you have multiple internet service providers or you have more than one WAN access. For me and my network, I do not have more than one WAN or internet service provider. But in this case scenario, as you can see, you would have two IPs from your internet service provider. And the second IP, the public IP address, you would use for your web server. And so you would basically just go into the WAN setting. You would make sure you have either WAN 1 or WAN 2 set with a static IP from your internet service provider. And then what you would do is you would go ahead and go to transmission NAT 1-to-1, and then you would create the mapping of that server. So for their case scenario, they map their web server 192.168.0.200 to the public IP address of their internet service provider. Now this probably won't work if you're trying to do one-on-one NAT translation if you only have one internet service provider. So just be aware of that. Typically this service is not used unless you're going to be hosting a device and you want it available to the internet where other people could use the device. Something similar to that, where you want to forward specific ports of a server or computer on your subnet, you could do that here in virtual servers. Now, virtual servers also acts as port forwarding. So if you know it by port forwarding, it's basically the same thing. So for my case scenario, I do have a Mediaplex server and an IRC server. And so what I did is I created the external port for that device, the Plex server, to be open, and the internal port along with the actual internal server IP address. So now when I want to collect and connect to my Plexi server, I could do so forth because the ports are being forwarded, or they're acting as a virtual server. So as you can see here, the IRC server also has the same things, port 7000 for the specific designated IP for that device. So you could really go pretty crazy with port forwarding if you have a lot of devices that need to serve other people outside of your local network. And please be aware that virtual servers cannot contain the same port number. So if I try to create a secondary IRC and then put port 7000 for both external and internal, with a different IP, of course, it will say I can't do that because there's already a device on this network or on this router that already has 7000 associated with it. So just know that you can't duplicate ports or open port forwarding for multiple ports of the same kind. So next we have port triggering. There is similarities between port forwarding and port triggering. However, the main differences are stated here. So port triggering can be used by any computer on your network, although only one computer can be used at a time. And port forwarding is configured for a single computer on your network. Port triggering does not require that you know the computer's IP address in advance, whereas the IP address is captured automatically. And port forwarding does require that you know the specific computer's IP address during the configuration, and the IP address can never change inside of port forwarding. And then port triggering requires specific outbound traffic to open the inbound ports, and the triggered ports are closed after a period of no activity, whereas port forwarding is always active and does not need to be triggered. So it's fairly straightforward to configure. You just give it select an interface, so your WAN, then your name, then you select the ports, the type of protocol, and then the incoming port, and then the protocol, and then enable. Fairly straightforward. Same thing with NAT DMZ. You could put a specific device on a demilitarized zone, so that way it's not going to be associated with any other devices on that network, just in case if it gets hacked, because it's public facing, you won't have to face some serious consequences with the other devices. So you basically give it a name, you select your WAN interface or other interfaces that you have, and then you would give the host IP address. So say for example you're using a web server and it's on the scheme of 10.0.058, you would enter in the IP address of that web server here, and then from there it will be accessed as long as the virtual server is enabled. And so that's how that's done. For my case scenario, I won't be using port triggering or NAT DMZ as of now, and that might change depending on the certain security and rules that I have in place. And the last part of this menu is the ALG, and so this I do believe is the type of services that will be allowed on this device. So you got the IPsec SIP for PBX systems or IP phones. You got the point-to-point protocol, and then it looks like H323, which is like video streaming, and then FTP for FTP services. So for me, for now, I'm gonna just leave these as their default settings. If you're not running an FTP server or specific servers within this router's subnet, I would definitely say disable them. So for my case scenario, I'm not running SIP, I'm not running FTP, I would disable them. Eventually I will be running an FTP server and a SIP server for examples later on in the future, but I will just leave them default enabled for now. And basically that is it. There's a lot to do on this router. We could probably make this series a 2 to 3 part video to configure your business suit router, so that way your business is up and running. So we'll probably continue with part 2 and next video series. And if you need any consulting needs, don't hesitate to contact Telefox.